somewhere out there between Mars and Jupiter, there's a rock worth more than every economy on Earth combined. A single asteroid packed with enough nickel, iron, and precious metals to rewrite the global economy. It sounds like science fiction. But right now, real companies are building spacecraft designed to mine them. If they succeed, the first trillionaires may not be on Wall Street, they'll be in orbit. So, how do you actually mine an asteroid? And could this be the start of humanity's next great gold rush in space? Asteroid mining is exactly what it sounds like. Extracting valuable resources from rocks floating in space. Most asteroids are ancient leftovers from the early solar system, the raw materials that never formed into planets. Some are rich in metals like platinum, cobalt, and nickel elements we rely on for electronics, batteries, and green technologies. Others contain water ice, which can be split into hydrogen and oxygen, perfect ingredients for rocket fuel. If we could tap into even a fraction of those materials, it could power entire industries, not just on Earth, but beyond it. For decades, asteroid mining was a dream. Too expensive, too far, too complex. But suddenly, the numbers are changing. Launch costs have dropped dramatically thanks to reusable rockets from companies like SpaceX and Rocket Lab. Small satellites have become smarter and cheaper. And artificial intelligence can now spot promising asteroids from millions of miles away. A startup called Asteroid sent the first private mission to a near-Earth asteroid named 2022 OB5. Their goal? Test the technology needed to extract and refine metal in space. At the same time, NASA's Psyche mission is on its way to a metal-rich asteroid over 200 kilometers wide, a world made almost entirely of nickel and iron. It's a scientific mission, but what we learn there could unlock a new kind of economy. For the first time, asteroid mining isn't fantasy, it's business. So, how do you actually do it? Let's break it down into 3 steps. Step 1. Find the right target. Scientists use telescopes and spectrometers to identify asteroids with high concentrations of metal or ice. The best candidates are near-Earth asteroids, close enough to reach without spending a fortune on fuel. Step 2. Extract the material. This is where it gets tricky. In microgravity, you can't just dig with a shovel. Every push sends you drifting backward. So engineers are developing robotic drills, harpoons, and even microwave systems that can melt and collect metals. Step 3. Use it or bring it home. Some companies plan to return small, refined samples to Earth. Others want to use the resources in space, turning water into rocket fuel or 3D printing new spacecraft from metal. Or it's not just mining, it's building the infrastructure for a permanent presence beyond Earth. Here's where things get wild. Asteroid 16 Psyche is estimated to contain over $10 quintillion worth of metal. That's a 10 with 18 zeros, of course. That's a theoretical value. Flooding Earth's economy with limitless metal would crash prices overnight. But the point isn't to get rich quick, it's to create supply chains in space. Imagine satellites refueling from asteroid water, moon bases built with asteroid metal instead of materials, launched from Earth, and new industries operating entirely off-planet. The first company to make asteroid mining work could control $1 trillion ecosystem, not by digging on Earth, but by building in orbit. It sounds incredible, but the obstacles are enormous. Technically, it's one of the hardest things we've ever attempted. Robots must survive extreme heat, radiation, and years of travel. Communication delays mean everything has to be autonomous. Economically, the costs are staggering. billions to extract materials that might never make it back to Earth. Legally, it's still a gray area. The 1967 Outer Space Treaty says no country can claim ownership of celestial bodies. But newer laws in the US, Luxembourg, and the UAE allow companies to own the resources they mine. It's a race between technology, money, and international law, all unfolding hundreds of millions of miles away. Still, the payoff could redefine civilization. If we can mine asteroids, we could end resource scarcity and stop tearing up our own planet for metals and fuel. We could build space stations, factories, and habitats using materials already out there. For the first time, our growth as a species wouldn't be limited by what's left on Earth. In the 1800s, it was the California gold rush. In the 1900s, it was oil. In the 2000s, it might be asteroids. The only question is, who's going to strike gold first? If you want to understand how space is quietly becoming the next economic frontier, make sure to subscribe. This is just the beginning.